So I'm Mike Hojnowski. I'm the advisor for the Amateur Radio Club at Cornell, W2CXM. And because I have an interest in ballooning, our students often get interested in launching a balloon payload. So we had a member, geez, this is probably about 4 or 5 years back, who was interested in the notion of could we put a parafoil on a payload and autonomously guide it as it descended unpowered back toward launch site or to some predetermined location. And so we said, oh, that sounds interesting. So let's look into, baby steps to doing a project like that. So we went and bought a couple of 1.4 meter kites. There's a picture of one there shown, and a bunch of other stuff, servos and payload boxes and things. But then sort of student life happened and she got really, really busy, and so the gear just sat there for a number of years until students this past year got interested again. So we went with a more simplified approach. This time, in the interim period, we switched over to using the Horus family of products for tracking. We've gotten really good at tracking, but one problem we find is that we often get right to where the payload's coming down and we watch it land right in the trees next to us. You can be in square miles of farm field, but those payloads manage to find the hedgerows and the patches of trees every time. So we said, could we simplify this parafoil thing, and rather than trying to do some automated guidance all the way down from altitude, just literally take control as it's coming in for its final landing and see if we can steer it a little bit, so instead of hitting the trees, we hit the open field or the rural road near us. So really the idea was, just from the FAA approved 400 feet, could we take control of that parafoil and start steering the payload? So that was sort of the approach we thought this year might be simpler to do. So as we looked at doing a project like that, we considered that the challenges. One big one is how do you keep the parafoil from tangling? As you know, even with a conventional parachute, more often than not, if you don't cut away the balloon, the parachute's going to be tangled up somehow on the way down. And obviously with the parafoil, that's an even bigger problem than it is with the balloon. The other issue was like, well, all of our prediction software is set up for free-falling balloons under a non-steered payload, but a parafoil is going to impact the direction that the payload is flying. So is the parafoil going to so mess up our predictions that we're not even going to be able to get to the landing site in time? And then finally, when we want to assert control, what technology are we going to do for that? We had originally thought of, again, using like a microcontroller to control things, but if we're not going to do that, are we going to use like low-raw and send commands, or are we just going to go with standard remote control hardware? What do we do to take control? So we created a plan. We're going to devise it such that the payload was protected. It's sort of hidden inside the payload box, and we released the parafoil, near apogee, and we sort of released the payload and parafoil so that it has a chance to deploy cleanly and away from the balloon. So we're basically going to cut away the balloon and have the parafoil open that way. And we were going to use commercial remote control airplane servos and receivers and radios, and also a low power FPV camera so that we could, as it got near the ground, see which way the payload was going, see the trees, and try to avoid them. So that was the thinking. So we came up with a payload design that looks sort of like this. The release mechanism is a little purple box down at the bottom here, and it would release the payload string, which is in red. And when this red string is released, it pulls off this blue cover, and then underneath that cover is where we have the parafoil, which is attached to the gold payload box. So the idea is that on ascent, the parafoil is not flailing in the wind, it's not doing anything. And when we cut away and yank away this blue box, the payload goes into free fall, the parafoil should theoretically open up cleanly and have less chance of tangling. For steering, what we did is from a side view of the payload box, on each side of the payload box we have a control arm here attached to a servo in the center. The parafoil kite that we bought has 3 lines that come down to handles on each side, and so we basically detach those 3 lines from each handle and attach the center one right to the payload box, and the front and back lines to this servo arm that'll tilt left or right. And we do that on each side of the payload box. So the two servos working in tandem should be able to provide steering for the chute. So here's the payload box we came up with. We had a lot of people very interested in making the payload boxes pretty, so they're all painted up and have space themes on them. So the lower gold payload boxes here, you see there's a control arm with a couple of loops where we would attach the parafoil, and right in the payload box, you see there's between those two white arms, there's a hook to attach the center line of the parafoil on this side of the box. Above it is this blue cover, and you can just see some of the strings sitting on the top here. These white bars going up and down are just more or less protection. If this thing kind of spins around, as payloads like to do, there's going to be a lot of torque on this control arm toward the outside, and we were concerned that, you know, if the payload box really whipped around, could it just rip this arm right off the servo? So these little these are basically a slot on each side. The control arm is inside that slot, so if it tries to pull beyond that slot, it'll get a little bit of assistance in not torquing too hard. Things didn't line up just right, so you see they're crooked. That's just allowed us to put them in such that we had a full range of motion with each arm, because we wanted range of motion more importantly than pretty. So we decided to mount them crooked but get a full range of motion from the arms. So inside the payload box, it's a mess here. Nothing is secured, but this is just to give you an idea of some of the stuff that's inside the payload box. Here's the release mechanism, dead center in the middle of the bottom of the payload box, and that is a quick release clamp here that is controlled by a servo inside that little box. The blue box in the lower left is a low-raw microcontroller, a TTGO T-beam running on 433 megahertz. So we can send that control from a ground station, and it's going to actuate this servo and open it. So this little blue control box will be in charge of releasing the payload at altitude. We've tested this low-raw stuff in previous flights, and it shouldn't be difficult to receive a signal at near apogee to say cut away the balloon. This little black thing, the R9SX here, is a standard FreeSky remote control module running 900 megahertz. The antennas are just laying here on the bottom. So it's a 900 megahertz remote controller receiver that attaches to the servos that we're using to steer the parafoil. So just using standard over-the-counter stuff for steering that. This 900 megahertz is more than we need. Normal cheap remote control stuff runs on 2.4 gig for short range. We just happen to have the 900 stuff, so we used it, even though we don't really intend to control it from that high up. What else do I have? Any other notes? No, I think that's it for this one. Next picture here is a couple pictures of the payload box. In the side of the payload box, we have an action cam pointing outward to get the mandatory flight pictures. And on the cover, this is the cover of the payload box, not the cover for the parafoil. You'll see there's a camera here facing upward, and the idea was to catch the parafoil deployment when it comes out. These four pegs in the corners are basically there to keep the blue cover from sliding off. And this hole in the middle is where the payload string comes right through and through the cover. So hopefully, when we have a deployment and the cover is yanked off and the parafoil would just be laying on top of this white section here, sort of curved between the around where the central section is there. Hopefully, we would get a good view of the parafoil as it deploys. And the dash cams the cameras we always set up in sort of dash cam mode. When we apply power to the payload, the cameras just come on. That really simplifies getting the payload ready for flight. Also, I mentioned previously an FPV camera. This is just a cheap $20 FPV camera, analog. And it's got just a tiny little flower antenna on top, but from a few thousand feet away, if it's coming down from altitude, we should be able to get video, forward-facing video of the payload as it's coming down. So just a real simple, cheap first-person view that'll give us view as we're coming in again, so we can try to steer because depending on line of sight and where we're parked, and where the payload is, we may not see the payload well and know what it's coming into. So we're hoping the FPV camera will give us a better view. And somehow it is next foil. There we go. From the ground, we have a couple of ground stations. The upper one here is the low-rod ground station. And we built these a couple of years ago for a bear drop payload. So you see we have bear drop on there. And then payload drop was actually sort of the parachute cutaway. So if we were stuck in a tree, the notion was we could cut away the parachute and just drop the payload. And it also controls a buzzer in the payload, and this lock switch was intended if we had automated drop, automated cutaway, we could actually lock that out and say, don't do the automated cutaway, keep going. So that's what those switches were for. Then we just retasked this. So basically the bear drop is the cutaway, the balloon switch for us now. And we did stick the buzzer in the payload, so we do have a buzzer if we want to try to find the payload on the ground. And it's got a little low rod receiver here, and it puts a little telemetry in that tiny display you can't read. And also the free sky radio for the parafoil, and this just controls the servos on the parafoil. So literally the only thing that operates on this is the right-hand joystick, which controls the elevation, the elevators and the ailerons are in this configuration, sort of elevon configuration. If you've ever used flying wings, that's the same configuration. So I have a video here of the payload box in operation. Oh geez, it probably won't work because I'm not in the slideshow view. Zach, can you turn on audio for a minute and let me know if we can see the slideshow this time or not?
Yep, I'm here.
I'm just going to try it and see if it plays. Are you seeing it?
No, it's not changing.
Okay. So we won't bother. Basically, it was a walkthrough of the payload box and showing the cover coming off when I activated the servo. You can see I had a string here through the loop on the quick release clip, and basically I walked around the payload and showed through the switch on the remote control and showed how the cover comes off and how things would deploy. So that was what that was. Again, the remote control gear, I covered most of this. Standard free sky over-the-counter R9 900 megahertz gear. The servos were heavy duty. I think they're 40 kilogram servos, so they should be strong enough to actuate and operate the control arms, which are basically in an elevon mix. If you're familiar with flying wing configurations. So with all this said, our testing plan was to do some drop tests. The advisor, me, I have a heavy lift hexacopter, and the intention was we would put the payload under the hexacopter, take it out to the local fairground and drop it from a few hundred feet and get a feel for how and if the parafoil would control the descent. And the short answer was I crashed the hexacopter and we couldn't do that. I went out to do a test flight beforehand, and something on the hexacopter failed, and it came down really hard and broke really hard. So life happened again. During pre-drop testing, the hex crashed. So then as spring was coming, for those familiar with the winds aloft and the academic schedule, really the winds aloft in our area are good through like the first month of school in the fall. And then the winds aloft are crazy and maybe get better just around exam week. And so we thought, well, all right, just before exam week, during study week, we're just going to cowboy it. We're going to launch this thing and see what happens. And if it doesn't work, it doesn't work. But then the weather and horrible predictions kicked in, and basically, if we had launched at the end of the semester, we would have had to drive about 100 miles between launch and landing, and it wasn't feasible. So we couldn't drop test, and we couldn't just cowboy it, so we didn't launch. So plan B at this point is I'm repairing the hexacopter, and that got more involved than I had hoped. I had actually hoped to do some drop tests before GPSL, but the hexacopter had more extensive problems than anticipated. So at this point, we do have a couple students in town for the summer who are interested in doing drop tests, so I'm hoping in July or August that we'll do some drop testing so that we can do a launch in the fall. And so I had hoped to have more information or even some video of the test flight for this presentation, but life keeps happening to this project, so we just keep going with the blows here. So what are some concerns or things that we're still worried about with this? Again, that the parafoil may cause a serious variance in the predicted landing. So another thought I've had recently is maybe we use a traditional chute with the payload and and have sort of the normal payload string and let the balloon pop, let the traditional parachute bring it down, but still have that cutaway in the payload box that we use much closer to the ground. So as we get, a few thousand feet off the ground, we cut away the main chute and allow the parafoil to deploy so that we can control it from there. And I'm thinking I might want to do that. Again, without the drop testing, we don't know the control authority of the parafoil or whether it's going to deploy cleanly and what its default behavior is going to be. So I expect the first drop is going to be pretty panicky on the controls, trying to figure out how to make this thing come down cleanly. And the other issue is that the payload box is too pretty. People were really interested in making the payload box pretty, but we need to do drop testing, and that drop may be violent. It may not work, and it may destroy the payload box a couple of times. I'm sort of anticipating a payload box covered with duct tape before we finally get everything working right. So I'm going to build a throwaway box for the drop tests so that the pretty box can be used for the real flights. So that's where we are with this project, and I just figured with greater minds around, I would say this is what we're thinking. What do you think? Does anybody have thoughts about things we should try, things that what they know would work or won't work, or concerns? We know nothing about parafoils, so I'd like to throw it back to you guys now and see if anybody has thoughts.
I'm going to bring Mike up to you so that you can.
I don't have to read it. Yeah, Mark Garrett here. Just curious, what is the weight of the throwaway box, and do you feel that any of the box dimensions will throw off the parafoil?
So I haven't weighed it yet. I mean, it's under the 4-pound single payload limit, and it's the size of the payload box. It's pretty blocky, so it's not aerodynamic in any way. So that is a concern. I've seen other projects with parafoils that use very narrow cylindrical kind of payloads, and that's a concern. But I'm hoping we find out with drop testing whether it'll work or not. We could potentially make something streamlined that may actually guide the airflow around the payload box, and that's a thought.
Questions or comments?
What are the cameras?
Harry's asking what are the cameras you're using?
They're cheap action cameras off Amazon. They're like $20 a piece or something. They're GoPro lookalikes. They're just 4K cameras. If someone's real interested, I could look it up after and send a link. I think they're the same cameras that 50 different people put a label on.
Anything else? Michael, did you want to touch on that FAA committee?
Sure. So I can touch on that as well. There's another activity going on that Zach asked me to talk about, and I know that Jim and Bill are familiar with it as well. Zach, can you mute that again? It's hard to talk when you hear yourself. Okay, so there is an FAA initiative, or excuse me, a congressional initiative to look at making changes to Part 101 balloon regulations. And that's in response to the China balloon thing that we talked about last year. And since the ARRL became aware of this potential rulemaking change, they put together a subcommittee to gather feedback from ARRL members and people in the amateur radio ballooning community, and got themselves a seat at the table with the subcommittee that's looking at changing Part 101 so that our feedback could be provided. So I think that's a great thing that the ARRL is doing. And so they just sort of organically reached out and said, hey, who's interested in this? And so, these are the people I know that are interested based on, who's on the email distribution and who I've seen in the meetings, and I may have missed a few people. But these are people that Steve Goodgame from the ARRL got in touch with, myself, Bill Brown, Seth Kendall, who he and his son are involved with the New England Ballooning Society, Joe Bizzarro, I believe, is also involved with those folks, the Stratospheric Ballooning Association, Matt Nelson chairs that, and I believe Bill was also involved with them. And Matt Genke from the ARRL is also involved, and I saw that Jim was at the last meeting from EOSS. I don't know if Jim or Bill, you noticed any others who were on the group that I missed, but those are the people that I remembered. So the current state is nothing much has happened yet. The committee got together once so far. Steve attended. He reported that the primary interest seems to be having one pane of glass for the flight controllers, which has balloons on it, and getting that balloon telemetry available to them. When pressed, they may only care about non-exempt flights, the heavy ones. So those of us who fly non-exempt may not see any changes, but again, that's answer fuzzy, try later. So the feedback we've given to Steve, and again, I'll ask Bill and Jim to chime in if they remember anything else, is basically, ADSB really is a non-starter for most amateur flights. They're heavy, they're expensive, so we'd rather not have to use ADSB. We'd like to keep any additional regulations they want to invoke on us in the non-exempt payloads only, at least that limits the impact of the ballooning community, and typically the exempt payloads often have more funding available than the non-exempt ones do. And finally, the FAA, one thing we pointed out is that the FAA already has their flight ID system for drones. And could that be leveraged for balloons, so that, if a drone is in the air, theoretically, it's reporting its position and its owner. Could a similar thing be done with balloons? Hardware to do that is lower cost and lighter and plentifully available since it's used by the droning community. And so that's the feedback we provided so far. And again, after I'm done, we'll let Jim and Bill chime in if they remember anything else. So the next steps, as I know them, there are regular meetings of the Congressional Subcommittee. Steve is attending. There's one every couple of weeks, and we meet every other week. The ARRL advisory folks meet every other week just to hear what's going on and give feedback. The timeline for this legislation change is fall, which is pretty aggressive as this kind of thing goes. And that's what we know. So again, I'll open it up if Bill or Jim have any other thoughts or anybody has any questions, but that's what we know right now.
Yeah, basically, first of all, if you go to your first slide, Steve Goodgame's call is K5 Alpha Tango Alpha. Your very first slide.
Alpha Tango.
Yeah. And he's basically wants to reach out. I had a long chat with him at the Dayton Hamvention, and it's great that he's on that committee. That's the right person to be out there with the backing of the league. So, and he has organized this group of informal input from some of the representatives from the ham radio ballooning community to give him some feedback. And he will periodically, probably I think he said 2 weeks, we'll be meeting with our group, Mike, I think that's what he said, to give us any updates, and then we can spread the word to the general ballooning community. So, and we do have, Jim, you're on that list, so you'll be getting an email on our next meeting to have the OSS represented with that too. And by the way, Jim, can you enlighten us how much an ADSB transmitter cost and what it takes to get one activated. So here's Jim.
Okay. Well, first of all, Steve was saying that the first face-to-face meeting of this FAA committee is going to be the 17th of this month in Washington, D.C. He'll report back to us on what's going on there. And one of our members pointed out that there's probably some interest from Homeland Security and Department of Defense in this thing too. So we need to warn Steve that some of the people that are sitting in that committee and not saying anything are probably more influential than the FAA people are. But let's see, what were you just saying, Bill? Oh, ADS-B. Yeah, we do fly. We have 2 ADS-B units. So we fly on our non-exempt balloons, and they cost on the order of $3,000 now. And packaged up with a battery set, they weigh about 600 grams to fly, so it isn't trivial. One thing neat about them is that you do get assigned a tail number, and so you have a much better relationship with the FAA, and they actually see you on their screen, and they recognize you as an aircraft. Yeah, we were able to obtain our first one with our funds, and actually some wheeling and dealing with the manufacturers, and they gave us a unit that hadn't been certified yet. Now we don't need to have them certified for aircraft use. So possibly we can get something less than that. The other unit was bought by the university that we fly for. University of Colorado bought it and donated it. So we flew that, but looking at getting a third one, we are talking $3K at least.
What's it take to activate one?
To activate it is just a matter of filing the paperwork with the FAA, I guess similar to an aircraft. And when we did that, we actually got 3 tail numbers assigned, so we've got a third one ready to go.
Is there a fee for that? How long the process is that?
Fee and length of process, I don't know if there was a fee. If there was, it was pretty trivial, $100 maybe. And as I recall, it only took maybe 30 days to get that put in place. So, yeah, that, from what Steve was saying, that may be coming for non-exempt balloons, and if we can work it right, be exempt from that for exempt balloons, which would cover most of the ballooning community, I hope.
Thank you. Thank you, Michael. Thank you, Bill and Jim. Anything else for Michael?
Thank you so much, and if anybody has any comments or feedback, let me know.